So, on problem number 1, what is the smallest number of coins that can represent $1.56 using quarters, dimes, nickels, and pennies if all coins must be represented? So, on the question, the given amount is $1.56. By using my program, the result will be number of quarters is 5, number of dimes is 2, number of nickel is 2, and number of penny is 1. Why? First, in quarter, I use the formula integer. I use integer because of the decimal points like 0.25, 0.10, 0.05, and 0.01. That is why I use integer. So on the total amount of quarter on the given will be equal to dollars divided by quarters minus 0.25. On dimes, integer parenthesis dollars divided by dimes. And on total amount of nickel will be integer parenthesis dollars divided by nickel close parenthesis. On pennies will be integer open parenthesis dollars divided by penny close parenthesis. So on print, I printed number of quarters, comma, then the value of quarter, total amount of quarter. Then next is print number of dimes, comma, and the total amount of dimes. Print number of nickel, then comma, the total amount of nickel, and lastly print number of penny, comma, and the total amount of pennies. That's why I come up with these numbers. So on problem number 2, if the surface area of a spherical tank is 2000 square meter, solve the volume of a sphere. I used import math because we will be using pi or math.square root. Then if we run this program and enter the given surface area, which is 2000 square meter, the volume of the sphere will be equal to 8408.749 etc. square meter. Why I come up with this amount? Because I used the formula surface area powered by 3 halves divided by 6 multiplied by square root or pi. Then on print, I used volume of the sphere is equals to, then I added string to the volume and plus the string on the unit. That's why I come up with this, the volume of this sphere. On problem number 3, find the volume of a right circular cone of radius 5 meters and a height of 6 meters. I used import math because we will be using the numerical value of pi, which is the 3.14 etc. And for the volume is equals to the 1/3 multiplied by pi multiplied by radius squared and multiplied by height. On print, I put the volume of a right circular cone is, then comma, then for the formula. If you run the program, it should be like this. The given radius is 5 meters and the height is 6 meters. So the result will be 157, which is the volume of a right circular cone. On problem number 4, find the volume in cubic meter of an open top box having a dimension of 200 cm by 300 cm by 50 cm. So the unit of measure is cubic centimeter, while the formula I used is length times width times height. I separately divided it by 100 because the given is centimeter, so I need to convert it by meter. If I run this program, enter the length in centimeter. So the length is 200, while the width is 300, and the height is 50. And I come up with the answer 3.0 cubic meter, which is the volume of an open top box. Why? Because this 3 cubic meter is from the formula I used, which is the length times width times height. On problem number 5, a car accelerated from rest and reached the top speed of 120 miles per hour in 10 seconds. Solve the acceleration of the car in kilometer per hour squared. So, time multiplied by the value of 10 seconds into an hour. This is to convert 10 seconds into an hour. And for the acceleration, it is the velocity final minus velocity initial divided by the time, which is the hour. And to convert the final answer, we will be converting it into kilometer, which is the acceleration multiplied by 1.6934. This 1.6934 is the value of 1 mile in kilometer. The unit will be kilometer per hour squared. So if we run this program, the final velocity is 120. The initial is 0 because there is no given initial velocity, and the time is 10 seconds. So we come up with the value of 69,517.926 etc. kilometer per hour squared, and this is the acceleration of the car on the given problem. So on problem number 6, a body is dropped from the building and reached the ground in 8 seconds. What is the height of the building? What is the velocity of the body as it hits the ground? So for the given acceleration, we use the gravitational constant in meter per second squared, which is 9.81. And the unit for number 1 is meter, while the unit for number 2 is meter per second. I use the formula for the finding of height, which is the initial velocity multiplied by time plus 1/2 times acceleration times the time squared. And for the velocity, I use the formula initial velocity plus the acceleration multiplied by time. If I run this program, the initial velocity is, let's say, 0, and the change in time is 8 seconds. So for the height of the building, we get the result of 313 meters, and this is the height of the building. And for the velocity of the body as it hits the ground, we get the result of 78 meter per second. But if we calculate this on calculator, this is not the exact amount. This is rounded off to the nearest tenths. By solving number 8, find the limit of x squared minus 25 divided by x minus 5 as x approaches 5. So first, I simplify the given equation, which is x squared minus 25 divided by x minus 5 into simple x plus 5. So the limit of x as x approaches 5 will be x plus 5. If I run this program, x approaches 2, the given value of 5, so that we get the amount of 10. The limit of x squared minus 25 divided by x minus 5 as x approaches to 5 is resulted to 10. And lastly, for the challenge problem, I simply use the formula y is equals to mx plus b. If I will be getting the value of m, it will become y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And if I will be getting the value of b, it is y sub 1 minus m multiplied by x sub 1. And if we run this program, what is x sub 1? The value of x sub 1 is negative 2, and the value of x sub 2 is 3. The value of y sub 1 is 0, while the value of y sub 2 is 6. The equation given to the points is y is equals to 1.2x plus 2.5 0.4. And this is the equation that we get from the given points. That's all.